Hello everyone and welcome to part 9 of the SDL 2.0 tutorial series. In this video I'll show you how you can render TrueType fonts in SDL 2.0. And for that we will need the TrueType font library. And if you Google SDL2 TTF, it should be the first link there. So when you go there, we need the development libraries for Visual C++. And once you have that downloaded, I have it extracted in the C directory. So if I go to C, I have it right here. So as usual, we will need to include the include directories and the library directories for that. So we'll go to our project properties, and in V C++, we will include the include directory there. And in the linker, we will include, in general, we will include our library directory. So library x86 and then OK. And in input we will need to add SDL2 underscore TTF or SDL2 underscore TTF dot lib. And this should be it for our properties for the TTF library. Now, to move on to our code, we will need to go to our graphics class, and in that we will include SDL underscore TTF.h. So include SDL underscore TTF.h. And we'll need a couple of functions to add into our graphics.h. For that, we will need first an SDL underscore texture pointer function, and we'll call this one create text texture. And this will take a TTF underscore font pointer, we'll call this one font, and an std string which we'll call text. And you'll notice that it takes in a font and a string and it returns an SDL texture. And this is because of the way that SDL handles TrueType fonts. The way it's done is that you give it a string and a font, and it gives you back an SDL texture pointer with your font already rendered. So we will try to cache all these strings so that we don't need to re-render them every time. Every time we want to try to get the same string again, we will just bring it back in a map just like we did in our textures. And now we will need to go to our CPP file. For that, we will go to graphics.cpp, and from here we'll start by initializing our TrueType font library. So if TTF underscore font underscore init is equal to -1, that means an error happened, and we'll print f TTF initialization error. We'll pass it a string and a line break, and this will take TTF underscore get error. And this should be it for our initialization. So if this happens, we'll return false. Otherwise, we will return true. And now in our destructor, we need to quit that TTF library. So TTF underscore quit. And this should be it in here. We will need to do something in our game manager that we need to fix that we had before. We need our asset manager to be released after our graphics. This way we can release all the SDL items before we close our SDL library, because our graphics.cpp calls SDL underscore quit. So just make sure that you have the asset manager's release before the graphics release. Now to move on to our function that we created in our .h file, and this function is the create text texture. We'll have this one underscore our load texture function. So in here, SDL underscore texture pointer, and we'll call this one so graphics create text texture. This will take a TTF underscore font pointer. We'll call this one font, as well as an std string called text. Now in here, it will look a lot like this one. So SDL underscore surface pointer, and we'll call this one surface, is going to be equal to TTF underscore render text solid. And for that, we will have font, and then text dot c underscore string, because we're passing in a string and it needs a constant char pointer. And finally the color, and for now we'll have the color as black, so 0, 0, and 0. Later on we'll come back and change that color. So 0, 0, and 0. And we need to just do error handling just like we did before. So if the surface is equal to null still, then we need to output to the console. So printf text render error, and we output this error, which will be TTF underscore get error. And if this happens, we'll just return null. Next up is to convert our SDL surface into an SDL texture, just like we did here. So we will create an SDL underscore texture pointer and call this one text, which will be equal to SDL underscore create texture from surface. And this will take in our surface, as well as our mRenderer. So mRenderer, renderer, as well as the surface. And if texture is still null, we will do error handling as usual. So if text is equal to null, printf text texture creation error. And this will take in a string and a line break. And this will be SDL underscore get error. And then return null. Now, if all this worked correctly, we can just free our surface and return our texture. So SDL free surface, which will take our surface, and then return our text. And this will be it for our graphics class. So we initialized our library, we closed it, and we created our create text texture. Next up, we will move to our asset manager. And the asset manager will serve as a cache for a few other things that we will need to do. So in here, we will have a few extra maps. So std map std string. This will be SDL underscore texture pointer mText. And this will hold all the textures of the text that we created, as well as an std map std string. And this will be TTF underscore font pointer. We'll call this one mFont. Now, we will need a couple of functions to deal with our font loading, as well as our getText function. So SDL underscore texture pointer get text, and this one will take an std string called text and an std string called file name, and then finally an int size of the text that we want to render, and a private function called with return type of TTF underscore font pointer, and we'll call this one GetFont. This will take an std string. We'll call this one file name, and a size. and of course the size is an int. And this will be it for the two functions that we'll need. So now we can move on to our CPP file. In here, the first function we will need to create is our GetFont function. So TTF underscore font pointer, asset manager, GetFont. This will take an std string called, what did we call it back here? File name. So file name, as well as an int size. And this will look very familiar because we're caching the fonts that we're loading so that we're not loading them over and over again. So the first thing we're going to do is get a full path. So std string full path is going to be equal to SDL underscore get base path, and our full path will full path dot append assets slash plus our file name. So the same idea as our get texture so far, but this is where it differs a little bit. We will create another std string called key, and the key will be our full path plus a charcast of our size, and this will give us full path, and this will give us a key that is unique to the file name of our font itself and the size. And this is because of the way SDL deals with opening fonts. When it's opening a font, it opens a font with its size as one of the parameters when it's trying to open it. And you'll see that in a second. So if mfonts at the key is equal to a null pointer, then that means we need to load up our font. So we'll say mfont. I wonder why I called it mfont. Mfonts. So this is fonts at key, and fonts at key is going to be equal to ttf underscore open font, which will take in our full path dot c underscore string, as well as our size. And if mfonts at the key, it's still a null pointer after trying to open it, that means that we need to output an error to the console. So printf font loading error, and this will take a font dash string as well as an error dash string. And this is so that we know which font caused the error. So the first parameter will be the font that caused the error, which will be our full file name dot c underscore string, and the error will catch using the ttf underscore get error. Now all we need to do is just return our mfonts key. So return mfonts at the key. And this will be it for this function. The next function is a little smaller, and the next function is the getText function. So SDL underscore texture pointer, asset manager, get text, and in here it will take an std string called text, as well as an std string file name, and finally an int size. Now in here we will do the same caching, but we will need to use our getFont function. For that we will do a ttf underscore font pointer called font and this will be equal to get the font of file name as well as the size that we need. So if the font is not already loaded, it will load it for us and give us back our ttf_font pointer. And then std string key is going to be equal to the text that we want to render plus the file name plus a char cast of the size. And this will give us a unique key depending on the string that we're rendering as well as its size and the font that we're using. And then down here we'll say that if mtext add the key is equal to a null pointer, then we need to load up our texture. And from here we will say that our mtext add the key is going to be equal to the function that we created here. So create text texture. So graphics instance did we put it in? No, that seems fine. Interesting. So graphics instance create text texture. Wow. Create text texture, and this will take our font as well as the text that we want to render. So font and text. And finally, we will just return mtext add the key. And this will be it for our asset manager. All we need is these two functions. But the last thing that we need to do is to clear our maps, just like we did for mtexture. For that, we'll do a for auto text in mtext if text.second is not equal to null, then we need to destroy it. So if mtext.second is not equal to null, then we need to do an SDL _destroy texture, and this will take our text.second. Now finally down here we'll do a text.clear, and then next up we will do the same for the fonts. And the fonts are going to be for auto font in mfonts if font.second is not equal to null, then we need to close that font. And to close it, we will do ttf_close font, and this will be font.second. And then down here we will do an mfonts.clear. And that should be it for our asset manager. The final thing that we need to edit now is our texture class, because as you can see, the text is technically just a texture. And what we can do is add a new constructor here for the texture class so that we can give it a string and then it saves a texture for us using that string. So we'll go to texture.h, and in here we'll create a new constructor. So texture std string, so it takes in a text, an std string font path, as well as an int size. And that should be it for our constructor. So now we will go to texture.cpp and implement that constructor. So texture will be equal to an std string text as well as an std string font path, and finally an int size. Oh, we don't need that here. Okay, now we can go ahead and do the same thing that we did over here. So we will say that mGraphics is going to be equal to graphics instance. Our mText, on the other hand, is going to be equal to asset manager instance, but instead of get texture, now we want to get text. So get text, and the text that we want is this text. The string file name will be the font path, and our size. Now for clipped will be set to false because our text is not clipped, and we will do an SDL underscore query texture. And for that, we will put in mText with null, our width, so mWidth, as well as mHeight. So the same idea that we used over here in the default on the first constructor. Now all that's left is to set our render rectangle. So render rect.width is going to be equal to our mWidth. Our mRenderRect.height is going to be equal to m. Okay. And this should be it for our constructor. Now, the last thing that we need to do is to try it out and see if it works. In our game manager, we can do a texture pointer now instead of an animated texture. And here we will do a new texture, and this will take a string. So let's say we want to call it hello world. Now for our string, for our file name. For that, we can go open up the file, and I think I already have, nope, I don't have a TrueType font in here. So let me try to find one and add it to our texture. So debug in here, let's say arcade.ttf. So now we have one here. And we will also need the runtime library for the TTF library. So over here, the runtime binaries, I mean, so we will need the x86 one, and I have it downloaded already. We will need the libfreetype as well as our SDL 2.0 So these two here, and then we need to take them to move them into our directory for our exe. Now that we have those here, we can go ahead and try it out. So arcade.ttf, and let's say the size will be 72. Now we don't need to update the texture anymore. And so now we're creating it, we're moving it to 100 and 200 and rendering it. So let's see if it works. There we go. So it says hello world here. Maybe we can move it a little bit to the right. So let's move it over to 400. And here we go. So now it says hello world. So let's see now if our caching works. What if we create the same texture, a texture with the same parameters twice? Would we reload the file? So for that, let's go back to our game manager and create mtext2. So we will need to delete mtext2, as well as render mtext2. So here, let's duplicate this as well. So mtext2 will be the same as mtext1, the same hello world with arcade and 72. But over here, we will lower it down to, let's say, 400 and 400. So that's mtext2 position is going to be there. So let's see now if we get two textures onto the screen. And there we go. Now, if I go and put a breakpoint here, you'll notice that if I open up mtext, it's DFC 840. And in mtext2, I have DFC 840. So I'm not re-rendering the same thing twice. I'm just reusing the same one over and over again. And this is pretty helpful if you're trying to, let's say you have a scoreboard, you can make each digit in the scoreboard its own letter. And that way you can just have, let's say, 7 or 8 letters there that you can reuse from 0 to 9. It will cache all these textures, and then you can reuse them over and over again instead of recreating the scores texture every frame, which is pretty taxing. So this is it for this part of the tutorial. I think, where did we put the, oh, there it is. So for the color, maybe we should change the color. So over here it takes an SDL underscore color. Maybe we'll give the create texture an SDL underscore color as well. So over here we can do SDL underscore color, and we'll call this one color, and we'll pass it here instead. So instead of that, this struct that we are passing in, we'll just pass it in color. So this is in our graphics.h. So in graphics.h, in create text texture, let's give it an SDL underscore color, and we'll call this one color as well. Now we use this one in our asset manager, I believe, and in our get text. So in get text, maybe we will do the same thing here. So SDL underscore color, and we'll pass this one color, and this will be passed in here as well. And then asset manager.h in SDL get text, we'll do the same. So SDL underscore color, and we'll call this one color. So now that we have this, the only thing left is go to texture.cpp, and we can pass it in the color from here. So we'll do the same thing for this constructor. So SDL underscore color, and this will be called color, and we will put the color right here. So we need to go to texture.h and update that as well. So SDL underscore color, and we'll call this one color. Now if you go to the game manager, so all we did is just add SDL color at the end of each function that we had. And let's say we want to add this one. So we'll give it 255, 0, and 0. So that should be red. And we'll give this one 255, 0, and 0 as well. So let's see how this one goes. There we go. So now we have a red texture. So now that we added the color, we need to add it into the key for our asset manager, because over here we're only adding the key for that. So for this, all we need to do is to cast the color as well. So plus char cast of color dot red plus char cast of the color dot blue, as well as a char cast of the color dot green. And this will give us a key that will take the color into account as well, so that we can avoid a few issues with trying to render the same text but with different colors. So now if you go to the game manager, and let's say we give this one 0, but over here it's 255. So this should be green, I believe. There we go. So now we have one red and one green, but you'll notice that if I stop it right here, these two should have two different textures. So that's 9DC 900, and this one on the other hand should be different. So 9DC CB20, so it's different. Okay, so this should be it, but so one more thing that we can test if they have the same color, if we end up getting the same texture. So there we go. So ADC 840, ADC 840. So these are the same if they share the same color, the same size, the same font, and the same text. So this is it for the TrueType video. I do apologize for it being pretty long, but it is the most technical part of this tutorial probably. So I really hope that this helped. There are only very few things that are left so that we can actually start creating the game that we need. But I'm trying to set up a framework that we will not need to edit afterwards once we start making the game. And making the game will be very fast once we have a good framework set up. So this will be it for this video. Thank you very much for watching. If you have any comments, suggestions, or feedback, please leave them below, and I will see you on the next video.